Yes, students could able to see the screen.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So if we evaluate our task, what we did, we are talking about coordination compounds and stability of those coordination compounds. So stabilities are of two categories. One, thermodynamic, and second, kinetic. A thermodynamic stability is dealing with the extent of formation or deformation of bond, means it is related to bond, and kinetic stability is related to a speed of exchange of ligands. It is related to speed, kinetic. So kinetic Honda name you might have heard, or kinetic energy word you might be knowing. So it is related to speed. And we are starting now the second part, that's a kinetic stability. Actually we have started, but in detail mechanisms we need to think. But before thinking mechanisms, we need to know how can we decide whether complex can be labile. Labile means where speed of exchange of ligand will be fast, or complex can be inert. That we need to what find out. For thermodynamic stability, which factors do affect the thermodynamic stability that we discuss? But here in kinetic stability, it is not a very perfect word. Kinetic considerations, how can we decide lability or inertness? For that, one brilliant scientist, H. Taube, in 1952 had given few guidelines about decision of lability of the complexes. What he said, that I inform to you first. That concept maybe 10% only will be clear to you. But once I discuss the various examples, the concept will be the very clear, so that you can apply that concept to other complexes also. So what I am discussing, how to decide lability of the complex, that is guided by Taube. So what is the guidance of Taube? What are Taube's rules? That I am going to inform. What Taube said, if complex is, means of course we are talking about the octahedral complex. Complex is outer orbital complex, inner orbital, outer orbital, hybridization. In valence bond theory we have discussed. If it is an outer orbital complex, then a complex will be certainly labile. It is the first clause or first statement of Taube's rules. I repeat, what Taube said, if complex is outer orbital complex, means outer orbitals are involved during the formation of complex. Outer orbitals are involved for that hybridization. D2sp3 or sp3d2. These two types of hybridizations are possible for octahedral complexes. So outer orbital complexes means it is a sp3d2 hybridization. If sp3d2 is a hybridization, then complexes are labile. It is the first statement of Taube's rule. Is this first statement clear?
Yes, sir.
Yes,
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 sir.
and
sir.
I mean you only have to listen this. Secondly, what Taube said, if complex is inner orbital, then which hybridization will be there? Will you help me? What may be the possible hybridization? Yes, sp3 due to was the outer orbital. Inner orbital means waiting for completion. At least complete now.
SP3.
D2 sp3. sp3 means tetrahedral. I'm talking about octahedral complex. 6 bonds will be there. 6 coordinate bonds are there. So d orbitals are inner. Therefore, it is what? Inner orbital complex. If inner orbital complex is there, in such cases, one of the T2G orbital, what is T2G? That you know already, I'll explain that. One of the T2G orbital should be vacant, or if one of the T2G orbital is vacant, then only complex will be labile. Otherwise, it will be inert. I repeat, for outer orbital, previous clauses are there. Now for inner orbital, if complex is inner orbital, means T2sp3 is hybridization, then if one of the T2G orbital is vacant, then only the complex will be labile. Will you answer? T2G orbitals means how many orbitals will be there? T2G is a set actually. That T2G set means how many orbitals?
Three.
Yes, sorry, I could not hear that answer.
Three.
Three.
Right. 3. T for triplet. 3. Out of these 3, at least one orbital should be vacant by any means. Then only lability will be there. This is Taube's concept. Now question will be, why is it so? Let me discuss one by one. When sp3d2 is a hybridization for octahedral, then in order to obtain 7 coordinated intermediate. Yes, will anybody answer? When this 7 coordinated intermediate occurs in SN1 mechanism or in SN2 mechanism, where that 7 coordinated intermediate occurs? Could you able to understand what I am saying? Where that 7 coordinated intermediate occurs in SN1 mechanism or SN2 mechanism? Yes, students, you need to talk. In this dissociative mechanism or in this associative mechanism?
Associative.
Associative SN2 mechanism. So 7 coordinated intermediate occurs in SN2 mechanism. If 7 coordinated intermediate is there, means 7 is a coordination number, then number of orbitals which are involved also should be 7, which are 6 here in sp3d2. Those should be 7. So that hybridization should be sp3d2. In spite of d2, what should be there? D3. See, D3. This should be the hybridization for intermediate. Is it possible? If intermediate forms fastly or readily, reaction also will occur fastly. So intermediate formation is a very critical step in the chemistry, even in organic chemistry. So that intermediate formation, if easily occurs, then reaction will be fast. And when can it easily occur? If that third orbital, extra orbital than this previous two orbitals, is readily available, is vacant, is free. Anyhow, hybridization is outer orbital hybridization. So S orbital, then the p orbitals, all p orbitals, so 3 orbitals p3, and then outer d orbitals. Means if I consider first transition series elements, so those we say as a 3D series elements, then among 3D series, that 3D is a n minus 1 D. Afterwards 4s remains. It is called as ns. Afterwards 4p remains. It is called as np. Afterwards 4d remains. From location point of view, from position point of view, it is called as nd. So electrons are here only in 3D. So these orbitals are free. These orbitals are free. These orbitals are also free, but only was a need of 6 orbitals. Therefore, there was a D2 hybridization, see sp3d2. But now there is a need of 7. So for 7, the hybridization will be D3, not D3 only, sp3d3. And this D of 5 orbitals are there, no? Out of those 5, for octahedral complex formation, only 2 are used. For intermediate formation, 3 are used. If furthermore are needed, those also are available, but now those are not needed. Only 7 coordinate intermediate is enough, and therefore sp3d3 is a possible hybridization, is readily possible there, readily occurs there. And when it readily occurs, product fastly will occur. Product fast occurs means substitution will be fast. Substitution is fast, so complex will be labile. It is an explanation of the clause of Taube. I repeat, Taube said if complexes are outer orbital, then hybridization will be sp3d2. For intermediate formation, sp3d2 easily possible, orbitals are available. Intermediate formation easily possible, therefore reaction will be fast. Reaction is fast, so complex will be labile. That's a simple explanation. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Now, what about inner orbital complexes? Here, hybridization is D2sp3. It is for what? Octahedral complex. Coordination number is 6. And if I consider our mechanism is SN2, associative mechanism, and I want to obtain 7 coordinated intermediate, then for 7 coordinated intermediate, will you suggest me what should be this hybridization now? If 7 coordinate intermediate has to occur, hybridization should be, see, previously what happened? sp3d2 for for octahedral. For 7 coordinate intermediate, sp3d3. Now here hybridization or inner orbital complex is d2sp3. Then for intermediate, hybridization will be yes, please complete it now later. What should be the number of d orbitals? I want 7 coordinate intermediate. How many d orbitals should be there? Partly a computer search number. 6 means what? This 2d is 2. That's a 1s orbital means 1. And 3 p orbitals. 2 plus 1 plus 3 means 6. I want 7 here. Other numbers already given. I want only number for d orbitals.
D2.
D3.
Yes,
D3.
D3. So these three orbitals, here one orbital and here three orbitals. 3 plus 1 plus 3 is equal to 7. So 7 orbitals will be there. 7 bonds may possible. Coordinate bonds may possible. 7 coordinated intermediate may possible there by means of D3sp3. Now for that you need to properly understand d orbitals. How many d orbitals remain? Yes, 3, 5, 7. How many total? S orbital means always 1. P orbitals means 3. D actually is a sub level. Means how many orbitals? D sub level means how many orbitals?
5.
Right,
5.
5. And those 5 we divide in two parts. What are those two parts? One part is
3D.
no. One part. 3D is a one. One part of the D. Any D orbital. 4D consider, 3D consider, 5D consider. One part is in crystal 3 you have studied that. Splitting also you have done.
EG.
EG is one. Yes, right. EG. So I represent that. EG part. It is a one part by green color. And other part is one is EG. Other part EG means doublet. Only two orbitals are there. Yes. Other part is what is here?
T2G.
Right, T2G. Yes. Now you will understand what I want to say. When octahedral complex forms, which complex? Inner orbital complex forms, hybridization is D2sp3. So these d orbitals are used for hybridization. But when intermediate has to occur, associative mechanism occurs. 7 coordinate intermediate forms. At that time, we want D3sp3 as hybridization. D3sp3, remember carefully. D3sp3, so D3. So it is a 1, it is 2. So one of these orbital, which this orbital means, I want to say these orbitals means, which orbitals these are? Which orbitals these are? These orbitals
T2.
are, yes students help me. Which are those orbitals?
T2.
T2G orbitals. Out of 3 T2G orbital, this orbital, very important orbital, should be free, should be vacant. Then only that orbital will be available. Then only this D2sp3 hybridization will occur. Then only this 7 coordinate intermediate will occur. Then only the result will there or the complex will give the product because of associative mechanism. And then we can say that complex will be labile. But what is the statement? In case of inner orbital complexes where D2sp3 is original hybridization, if one of the T2G orbital is vacant, then such complexes will be labile. Why one of the T2G orbital? For this purpose, for that D3sp3 hybridization purpose, that orbital should be vacant. If that is not vacant, then how can that metal ion ask the foreign ligand to come in? Because 7 coordinate intermediate can't form, and if can't ask to come in readily, then how can reaction will be fast? I'm not saying reaction will not occur. Reaction will occur, but very low speed or no speed. Lability means speed. High speed means more labile the complex is. So lability is there for the complexes where one of the d orbital is vacant. So if I have to combine both rules, first rule for outer orbital complexes, they are labile always. Second rule for inner orbital complexes, one of the T2G orbital should be vacant. Then complex will be labile or else it is inert. Is this rule clear?
Yes, sir.
Yes. Now let us understand it by means of examples. Let us apply our learning for example. The first example I like to consider titanium complex, titanium aquo complex, TiH2O6 plus 3 or 3 plus. Here central metal ion is titanium plus 3, and of course 6 ligands are there. We are talking about the octahedral complex. So what may be the possible hybridization, is actual hybridization that I informed to you. Then I want answer from you whether that complex will be labile or not. Titanium plus 3, considerable a small cation is there. So it forms inner orbital complex. What it is forming? Inner orbital complex. So titanium plus 3, electronic configuration. Could you able to answer? Outer electronic configuration? Yes, in unit number 1 you have studied that orgon is there. But I'm talking about outer electronic configuration. Only 3D and 4s orbital. About did you talk? 3D?
3D1.
Right.
3D1.
3D1, 4s0, and of course other orbitals will be with 0 electron or no electron. I represent it in terms of the block d orbitals. 1, 2, 3, 4, 5 d orbitals. I represent s orbital. I represent p orbitals. 1, 2, 3. That one electron I represent here. And as I told before, I divide this thing in two parts. One part is EG part, last two orbitals, and one part is a T2G part, first three orbitals. For this complex TiH2O6 plus 3, which hybridization should be there? Which hybridization? I said inner orbital complex. So hybridization will be
D2sp3.
right, D2sp3. So I represent it here. See, these orbitals undergo hybridization, and in those orbitals, the electrons will be there. Electrons from whom? Ligands. Which ligand? A co-ligand. Water molecule as a ligand. 6 ligands are there. 6 lone pairs will be there. It is D2sp3 hybridization. If 7 coordinated intermediate is to obtain, then this hybridization should turn or change to which hybridization? What should be the new hybridization? It should be 7 coordinate intermediate. It should be
D3sp3.
right, D3sp3 hybridization. So for that we need one of the T2G orbital vacant. Now ask question to yourself. Is there one of the T2G orbital vacant? If yes, it is labile. If no, it is non-labile or inert. Is there T2G orbital vacant?
Yes.
So it's a labile or inert?
Labile.
Brilliant. Yes, here students you got the success to answer the question whether complex is labile or inert. And in JAM question paper also such questions do come. Your university question paper also is important topic. And understanding point of view is important. And whenever you will do research in future, further also it is what the important. You should know possibilities of behavior of the complex that you are going to prepare or the complex that you are going to work with which you are going to work. It is interesting. So it is our first example. Let me talk about the second one. The second complex is a vanadium complex I want to consider. Titanium I consider. Now let me consider vanadium. Vanadium H2O6 2 plus. 2 plus. Here central metal ion is vanadium plus 2. Vanadium plus 2. Can you tell me its atomic number vanadium or electronic configuration here? Okay, tell me first atomic number of vanadium.
23.
Yes, any other answer?
23.
Right. So 23, 3 is a last digit here. 3 is a last number. So for dipositive oxygen state, 3 electrons will be there in the d orbital. Those I represent in the block diagram. D orbitals. How many? 5. 1, 2, 3, 4, 5. Then s orbital and then p orbitals. Yes. Now 3 electrons I represent. First electron, second electron and third electron. If this complex is to occur, inner orbital complex I am saying, this complex is inner orbital complex. Then which hybridization should be there? Which hybridization should be there? Right, D2sp3, this hybridization should be there. And in those hybrid orbitals, ligands, 6 water molecules will put their lone pairs, and I represent the lone pairs here. So hybridization here is D2sp3. But if I want to obtain the intermediate, say with hybridization D3sp3, for that am I with any vacant T2G orbital? Is there any vacant T2G
No.
orbital? Here additional T2G orbital I need. Vacant, empty. Is there vacant T2G orbital? Is it available?
No.
No.
No. So this complex will be labile or inert?
Inert.
Inert.
Inert means it's non-labile complex, or complex is what? Inert. It is a conclusion. Is this second example clear?
Yes, sir.
Yes, sir.
Yes. Let us continue or grow our concept. A third example that I like to mention, iron aqua complex, FeH2O6 plus 3. So 2 plus, let me consider, or plus 3 also will be just plus 2. Here central metal ion is, yes, please help me. Central metal ion is Fe
Plus
2, right? Fe plus 2. And a hint I give it to you, it is outer orbital complex. This is outer orbital complex. Let us talk one by one. Fe plus 2. Its electronic configuration
3D6.
3d6, 4s0, 4p0, and if we need outer orbital, 4d0. Let me represent it in terms of the block diagram. I represent 3d orbital first. 1, 2, 3, 4, 5. I represent s orbital. I represent p orbital. I represent d orbitals. Here 6 electrons are there in the iron. So first electron, second, third, fourth, fifth, and sixth. 6 electrons are there. And I said the complex is outer orbital complex. Then what should be the hybridization?
sp3d2.
Yes, it's one of the s orbital, 4s orbital, then 3 p orbitals, there's a 3 4p orbitals, and then 2 4d orbitals. sp3d2 is a hybridization for whom? This complex. But for intermediate formation, we need additional d orbital. Additional d orbital. Is that d orbital available? Is it vacant?
Yes.
Yes, therefore rule says if complexes are outer orbital complexes, then always those complexes will be labile. Of course, here when I said sp3d2 as hybridization, then here the lone pairs from water molecules will come and they will enter here in those 6 orbitals. So this third example is of labile complex. Is this third example clear?
Yes, sir.
Yes, sir.
Good. Now let me talk about one more Fe plus 2 ion complex, and that complex is FeCN6 minus 4. Will anybody answer which metal ion is there?
Fe plus 2.
Right. What is electronic configuration?
3d6.
Right. 3d6, 4s0 and 4p0. One hint I give it to you, or before my hint also you might have guessed. Cyanoligand, Cn minus ligand is a strong ligand, powerful ligand. So what will it prefer? Inner orbital or outer orbital complex?
Inner.
Right, it is an inner orbital complex. So let me represent as usual our orbitals. The d orbitals I represent, of course, 3d orbitals. The 5 3d orbitals are there. Then I represent 4s and afterwards 4p. And in those d orbitals, the electrons are there. How many electrons? 6 electrons. First, second, third, fourth, fifth, sixth. So from first instance, you will feel where D2sp3 hybridization possible. Those two d inner orbitals are not available. But I said, how is cyano ligand? How is Cn minus ligand?
Strong.
Strong. So it will ask metal ion to make inner rooms available, and a poor metal ion will automatically adjust those electrons in inner orbitals, making available outer two orbitals, those Eg orbitals that we say, no? Outer two orbitals making available Eg orbitals, then 4s and then 4p. Yes, likewise here. Here D2sp3 is a hybridization. Therefore, inner orbital complex that I said. Okay, you understood up to here hybridization, which orbitals are involved, and in those hybrid orbitals, of course, the lone pairs from ligands will be there, and here ligands are cyano ligands or cyanide ligands, 6 ligands, 6 lone pairs. If D2sp3 is the original hybridization for the complex, then for intermediate, I want the hybridization as D3sp3. But for D3sp3, as per Taube's rule, one essential condition is there. What is that essential condition? Taube's rule, essential condition. Second rule, in case of inner orbital complexes, what should be available?
Vacant orb.
Yes, yes. One more. It is right. Vacant orbital. But which vacant orbital and where? Specifically,
T2G.
I said that. Yes, please.
T2G.
Right. One of the T2G orbitals should be vacant. Is it vacant?
No.
No. So will it be labile?
No.
So it is called as inert complex, non-labile complex. Yes, students, I plan to inform you lability and inertness by means of one kind of mechanism which is included in our syllabus with the help of Taube's rule. Let us know lability and inertness. It was my plan. And here with four examples, I had covered that. Are these all four examples clear?
Yes, sir.
Yes, sir.
So let us conclude our session by means of revision. Taube
Yes.
suggested the few rules to decide liability and inertness in 1952. What is said it as the first clause of the rule, you can say. In case of outer orbital complexes where sp3d2 is a hybridization for the complex, in order to get SN2 mechanism, sp3d3 hybridization for intermediate easy d orbital is available. Therefore, complex will be labile. Outer orbital complexes are always labile. It is the first rule. Secondly, in case of the inner orbital complexes, where D2sp3 is a hybridization for the original complex, and in order to obtain the 7 coordinated intermediate, we need to obtain D3sp3 hybridization. For that extra d, extra inner d orbital, one of the T2g orbital, that here, see, one of the T2g orbital should be vacant. And if it is a vacant, then the complex will be labile. So what the rule says for inner orbital complexes, if one of the T2g orbital is vacant, the complex will be labile. And we attempted to understand this rule by means of the various examples. The first example is titanium oco complex. Titanium plus 3 electronic configuration in a block diagram. Here inner orbital complex is there. D2sp3 hybridization is there. In order to have intermediate 7 coordinate complex, D3sp3 hybridization should be there. For that requirement is one of the T2 should be vacant. It is there. Therefore, complex is labile. Second example. Vanadium plus 2 metal ion, 3G3 electronic configuration. It is again inner orbital complexes. D2sp3 is a hybridization for the original complex. In order to get an intermediate 7 con intermediate via the mechanism SN1, D3sp3 should be the hybridization. One of the T2G orbital should be vacant here, but it is not, and therefore it is inert complex. Vacant orbital is not available, therefore it is inert complex or non-labile complex. Third example, it is an outer orbital complex, ferrous ion, 3d6 electronic configuration. Electronic configuration block diagram is represented. Outer orbital, so sp3d2 hybridization. So for intermediate formation, we need sp3d3. For that, one extra d orbital is readily available because nobody is there to occupy the electron. So therefore, beyond doubt, is the labile complex. Clause number 1, outer orbital complexes are labile complexes. And last example that we have discussed, a ferrous ion 3d6 electronic configuration because of strong cyano ligands. Here it is outer orbital, sorry, inner orbital complex. D2sp3 is hybridization, and for intermediate D3sp3 hybridization, if we have to obtain, then one of the T2g orbitals should be vacant, which is not. Therefore, complex is non-labile or inert. Students, did you get the point what I said?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, very soon I want to begin our experiments. Maybe from the third week of February, means 14th or 15th of February. Prepare your mind setup, whatever the issues may be there, but at least for experiments, you have to find a way. Proper, thorough understanding. If skills are to improve, let we have discussion, further interaction. How far you want, how more you want, I am there for you. Even for theory lectures also, if you are coming, I always welcome for the direct interaction. No issue at all. So students, you decide for theory if you are coming, always well and good. But if at least for experiments, are you ready to come?
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
Yes, good. I want the
Yes,
same
sir.
enthusiasm, same spirit, and the complete your journal also in time. By the way, complete assignments also. Whatever the video lectures I am conducting, I am uploading. Prepare the notes and upload those assignments. Yes. If you have any problem, any question, or any doubt, please feel free to ask. Yes, no doubt. Punam said, what about others? See, be honest and be clear can reply. Punam replied, Shruti replied, Ganesh replied, Alia replied. Yes, that's a way of student learning. Be clear cut in communication. If you feel I am not clear cut in my communication, bring it to my notice. I always want to be a clear cut in the communication. Yes, very good, very good. All have replied. Yes, thank you. We will see in the next time, but study well. Prepare the notes. I stop my today's discussion and I declare here today's session is over. Please quit.